Hey there, and welcome. Look, if you're a GIS pro, you already know that ArcGIS Pro is an amazing piece of software. But to really, truly let it sing, you need the right hardware. So in this explainer, we're going to break down exactly what you need to build a perfect PC for your GIS work.
Okay, let's be honest. We have all been there, right? You're just staring at that loading bar, watching that little circle spin, waiting for some geoprocessing tool to finally finish. Or maybe your map just stutters and lags every time you try to pan across it. It's like a universal pain point for all of us in GIS. But here's the secret. That lag, it's not always the software's fault. 9 times out of 10, the real bottleneck is your hardware. The right components can literally transform your workflow from a slow crawl into a dead sprint, and that's exactly what we're going to get into.
Now, I get it. You want the good stuff right away. So we're going to start with the too long didn't read version. Think of this as a quick snapshot of the ideal, balanced system that's going to make ArcGIS Pro just fly.
So, here it is, the magic formula. A modern 64-bit Windows system, a fast multi-core processor, a solid 16 to 32 gigs of RAM, a blazing fast NVMe SSD for storage, and a dedicated graphics card with at least 4 to 8 gigs of video memory. This right here, this is the sweet spot for most professionals. Now let's dig into why each of these pieces is so incredibly important.
All right, let's dive deep. We're going to focus on what I call the 4 pillars of performance. That's your CPU, your RAM, your GPU, and your storage. Once you understand how each one works, you can make way smarter choices for the kind of work you do. First up, the CPU, the central processing unit. The best way to think about this is as the heart, or maybe the brain of your workstation. It does all the heavy thinking, all the number crunching for pretty much all of your analysis and geoprocessing tools.
So what should you look for? I mean, yeah, you can get by with 2 or more cores, but the real magic for professional GIS work, it really starts when you hit that 6 to 8 core range. And if you're doing some seriously heavy-duty analysis day in and day out, pushing up to 10 or more cores is going to feel like a massive upgrade.
And this is exactly where all that power goes. A beefier CPU makes a direct, noticeable difference when you're running complex geoprocessing, wrangling huge raster data sets, running those multi-step models, or doing intense statistical analysis. If this stuff is your daily grind, a better CPU isn't a luxury, it's an absolute necessity.
Okay, next up is RAM, which stands for Random Access Memory. My favorite analogy for this is your digital workbench. It's simple. The bigger your workbench, the more projects and data you can have spread out and actively work on at the same time, without everything getting slow and cluttered.
So how big does that workbench need to be? Well, 8 gigs is, okay, it's enough for very light basic mapping. But the professional standard, and what we really recommend, is landing somewhere in that 16 to 32 gigabyte range. For all you power users out there, the ones dealing with enormous 3D scenes or tons of imagery, 64 gigs or even more is where you want to be. And here's why it's so critical. Things like high-res imagery, LiDAR point clouds, and complex 3D scenes are just incredibly hungry for memory. If you've ever had ArcGIS Pro crash or just slow to a painful crawl when you're working on a big task, a lack of RAM is very often the culprit. Simply put, more RAM means more stability and way better performance. All right, let's talk about our third component, the GPU, or Graphics Processing Unit. Think of this as your visualization engine. Its one and only job is to draw everything you see on the screen, making your maps, your layers, and your 3D models look silky smooth and feel super responsive. Now, you can technically run Pro without a dedicated graphics card, but trust me, having one is a total game changer. For most of us, a card with 4 to 8 gigs of its own video memory, that's called VRAM, is the perfect spot. But if you live and breathe in the world of 3D, like with urban models or heavy point clouds, pushing to 8, 16, or even more gigs of VRAM is going to give you that buttery, smooth experience you're looking for. A good GPU has a huge impact on your entire visual experience. It's what's responsible for rendering those gorgeous 3D scenes, for smoothly drawing those massive, complex layers, for creating map animations, and just for making the simple act of zooming and panning feel instant and fluid, not clunky. And finally, let's cover storage. This is your digital filing cabinet. It's where ArcGIS Pro itself lives, along with all of your projects and all your precious data. The speed of this drive affects literally everything, from how fast the application boots up to how quickly your maps and datasets load onto the screen.
So what are your options?
You can still use an old-school spinning hard drive, but really, an SSD, a solid-state drive, is the modern standard you should be aiming for. But for the absolute best performance, an NVMe SSD is the only way to go. They are just phenomenally fast. The perfect setup? An NVMe drive for your software and a second SSD just for your data.
So here's the blueprint for that ideal setup. You put your operating system and ArcGIS Pro on that wicked fast NVMe drive. Then you keep all your active GIS projects on a second fast drive. And this is critical. You always leave at least 32 gigs of free space for caching and temporary files. Pro needs that elbow room to breathe.
Okay, so we've torn down the components. Now for the most important part, connecting the dots. The goal here isn't to just go out and buy the most expensive parts you can find. It's about matching the hardware to the work you actually do, day in and day out. Just take a look at this. Someone who does mostly everyday 2D mapping might just want to focus on a good SSD and a decent GPU for smoother navigation. But on the other hand, someone doing heavy 3D and raster analysis, well, they need to go all in. A high core count CPU, 32 gigs of RAM or more, and a powerful GPU with tons of VRAM. Try to figure out where you fit on this spectrum.
To make all this feel a little less abstract, let's look at a concrete example. Here's a blueprint for a real professional-grade workstation that could handle pretty much anything you'd throw at it for years to come.
Here we go. You've got an 8 to 12 core CPU from Intel or AMD, a super comfortable 32 to 64 gigs of RAM, a modern NVIDIA RTX graphics card, and that awesome dual drive setup we talked about, a 1 terabyte NVMe for your system and a 2 terabyte SSD just for your data. This is a seriously powerful, well-balanced machine.
And that really brings us to the single most important takeaway from this whole thing. This isn't a competition to see who can buy the priciest parts. It's about being smart, being strategic, and building a balanced system that is perfectly tailored to your specific GIS workflows. So, I'll just leave you with this one final question to think about. Take a hard look at your current computer. Think about the work you do every single day, and just ask yourself, is my workstation helping me get my job done, or is it holding me back? Thanks for watching.